So these are our 1-2 notes, distance formula and Pythagorean's theorem. So today we are still talking about AKS IOA 3B, but we're going to talk about the distance formula and Pythagorean's theorem. So today's objective is that you can use the distance formula and Pythagorean's formula to find the length of a segment. That's what we're doing. Okay, so the distance formula and Pythagorean's theorem. All right, so the distance formula is derived from Pythagorean's theorem. So Pythagorean's theorem is a squared plus b, oops, that's not going to fit there. Let me try that again. A squared plus b squared equals c squared, okay? Where b is a leg and a is a leg. And where c, which is opposite the 90 degrees, this is the hypotenuse, okay? Hypotenuse, okay? That's our hypotenuse. So if a squared plus b squared equals c squared, and we can find the length of these two things, we can find b and we can find a, we can square those, then the way we're going to get the length of c is we're going to actually take the square root of this and take the square root of this, right? So that's how we get that c is equal to the square root of a squared plus b squared, okay? Now, the distance formula is a different setup. So what is the distance formula? The distance formula is the change in x squared plus the change in y squared. Now, this was derived from the Pythagorean's theorem. This is what we need to see, okay? So here again, this is the length. We just have the length here for a. This is how we find the length. We subtract x1 from x2 here, okay? So that's this point, right? x2 is there, x1 is there. See that? So that is the length of that side right there. That's equal to a, isn't it? And this would be the length of b. It's the change in y. So we started with y2 down here, and we ended with y1 up there. So we're subtracting y1 from y2 here, and that's what the distance of AB is, okay? So the distance formula was actually derived from Pythagorean's theorem. Important point to know, because the county loves to put stuff like that on the exam, okay? So now we're going to use both of these. So first we're going to use Pythagorean's theorem on the left, then we're going to use the distance formula, okay? So Pythagorean's theorem, we're going to plot point A, which is -1, 5 right here. So that's point A. And then B is 3, 1, right? 3 to the right, 1 up. This is B, okay? So we're going to connect those two. And what we're going to do is we're going to use our rise. This is going to be our B, right? This down here is going to be our what? A. So how long is B? B is 1, 2, 3, 4. That's equal to 4. A is going to be equal to what? 1, 2, 3, 4. A is equal to 4 as well. Correct? Okay, so what are we going to do here? Remember, we're doing a squared plus b squared. That equals c squared, right? So remember, when we're doing this, this is going to be our c, isn't it? Because it's our hypotenuse, opposite this right angle right there, okay? So that means we're going to do 4 squared plus 4 squared, and that's going to be equal to our c squared, or in this case, it's going to be ab squared, right? So this is going to be 16 plus 16. That's going to be equal again to our ab squared, right? Okay, that's 32, and that's equal to AB squared. Now, we don't want AB squared, right? We want AB. So what we're going to do is take the square root of both sides here. Okay? Now, I'm pretty sure all of y'all saw that we had 16 and 16, right? Isn't that the same as 2 times 16? So isn't this going to be the square root of 2 times the square root? Actually, let's do it this way. Let's do the square root of 16 times the square root of 2. This is how we simplify radicals, right? So 2 times 16 is 32, right? What's the square root of 16? It's 4. Square root of 2. So that's what AB is equal to in simplified radical form. Okay? Now we're going to do the same thing with the distance formula. Now remember, we did in the previous lesson, we labeled these points, right? So we did x1, y1, x2, y2. Now here's the other thing I want you guys to always know. Distance is never negative. So we're going to say distance is never negative. Okay? And both these formulas, both Pythagorean's theorem formula and this distance formula, which we're about to write on here, are on your formula sheet. Okay, this is the formula for distance. This is x2 minus x1 squared plus y2 minus y1 squared. So what we're going to do is we're going to plug those values in here. Now, what is the distance that we're looking for? AB, right? We're looking for AB. Okay, so we're going to take the square root of what? Our x2 is 3. Our x1 was minus a minus 1, right? And we're going to square that plus, again, we're just populating this formula, y2, which is 1 minus 5 squared. Okay, so this is going to be equal to, remember again, we got a plus, minus minus, so that's a plus. What's 3 plus 1? That's 4, right? So this is going to be 4 squared, right? And that's going to be plus a negative 4 squared. Anything you square always becomes positive because a negative times a negative is a positive, right? So this again is going to be the square root of 16 plus 16. That's equal to the square root of 32. And we just did that over there on the other side, right? So we know that this is 4 square root of 2. Okay? So what's similar, what's different? So obviously, ultimately, when we get to this point right here, we have the same thing we had over there on the left, didn't we? Okay, we did. Because remember, negative 4 and 4 is the same when we square it, right? So I need you guys to notice that the process, so the numbers, once we get a little into it, are very similar. Now, the thing I would say is it's easier to make a mistake with a distance formula than it is with just counting spaces, okay? So that's what I would, what I would use to kind of help determine which process I use, okay? All right, so example 1 says find the distance between. So again, we're going to go x1, y1, x2, y2, right? So remember, our formula is, distance formula is equal to x2 minus x1 squared plus y2 minus y1 squared, right? So we're going to put these things under the radical here. And again, we're looking at the length of AB, right? So that's going to be 4 minus a minus 1. Going to go ahead right now and make that a plus. Remember, we're squaring this. Squared plus, I'm going to make this longer. Then we got our y2, which is negative 19. y1 minus 7, right, squared. Okay, so that's going to be 4 plus 1. So that's 5 squared, right? And then we got negative 19 plus negative 7 is negative 26, isn't it? It is. So this is plus a negative 26 squared. So you can go ahead and do that in your calculator right there, okay? So this is going to be, what, 25 plus negative 26 times negative 26 is 676. So this is equal to the square root of 701. And that is going to be equal to, we'll say approximately, right? So you could try to see if there is a perfect square factor of that. Couldn't find one, so this is 26.48. Okay? So go ahead and do the next two. Come back to me when you're done. Again, x1, y1, x2, y2. So we're taking the square root of, this time it just said find the distance, so we don't know what the points were, right? So this is going to be 1 minus a minus 3 squared plus negative 2 minus a minus 6 squared, right? So I'm going to change this to a plus. I'm going to change this to a plus. Common error right there, y'all. So this is 4 squared, and that's plus 4 squared again, right? Let me double check my math, y'all. So we just did this one, didn't we? So we know that this is going to be the square root of 32, which is 2 square root of 6, no, 4. 4 square root of 2. Oof, 4 square root of 2, right? We just did this one, which is approximately, if we were going to round it, it's going to be 5.66, okay? All right, third one. Let's see if we can do this one. Again, you guys should have already done this, so if not, pause the video here and go back and do it. x1, y1, x2, y2, Again, square root here. Okay, so we've got our x2, which is 10 minus a minus 5, and we're going to square that, right? And then we got our 10 minus 5 squared. So that's going to be plus again. Y'all see that right there? Plus, so that's going to be 15 squared, right? Plus, that's 10 minus 5, so that's going to be 5 squared. So that's going to be 225 plus 25. That's going to be the square root of 250. Now, hopefully y'all can all see that this would be the square root of 25 times the square root of 10, right? Do y'all remember how to simplify that? Which means this is going to be 5 square root of 10. Now, we could compute that, right? We could just take the square root of 250, and if we do that, then that's approximately, because again we're talking about a distance, so that's approximately 15.81. Okay? Alright, so on this next one, it says find the distance between the 2 points round to the nearest 10. Now again, we could find these 2 points. So this one up here on the left is negative 5, right? And then this one right here is what? 1, negative 2. You could use the distance formula here, but you go for that. I'm going to use Pythagorean's theorem because I just think it's easier. So I'm going to make this guy right here my b, and that's 1, 2, 3, 4, 5, 6, 7. So b is equal to 7 here. And this right here is going to be 1, 2, 3, 4, 5, 6. So this is going to be a, and that's going to be 6. So then what are we going to find here? We're going to find C, aren't we? Isn't that what we're looking for here? Okay, so we're going to do, and that's the distance, right? So again, this is D, which was our C, right? C is equal to D. Same thing here, right? So we're going to do the square root, remember, of, because it's a squared plus b squared equals c squared. So this is going to be 7 squared plus 6 squared. That's 49 plus 36. And 49 plus 36 is 85. So the square root of 85. Again, try to see if you can simplify it. I don't think you can. So here, this is going to be an approximate length of 9.2. Okay? All right, let's do another one here. Okay? Again, going to count here. 1, 2, 3, 4, 5. Going to count over here. 1, 2, 3, 4, 5. So this is going to be my B. This is going to be my A, right? So this is going to be 5 squared plus 5 squared. We're going to take the square root of that. That's going to be our distance again, right? So this is going to be 25 plus 25. That's going to be the square root of 50. Okay. You should see that there's two 25s there, right? So this is going to be the square root of 25 times the square root of 2, which is 5 square root of 2. That is in simplest radical form. And then if we compute that, that is 7.1 approximately. If we're rounding, that's why we got the approximate there, okay? All right, so the next one here, you guys need to go ahead and do this one and come back to me when you're done, okay? So here is my height, 1, 2, 3, 4. Here is my width, 1, 2, 3. 1, 2, 3. So we're doing 4 squared plus 3 squared. Taking the square root of that, that's going to give us our distance, right? 16 plus 9. That's the square root of 25. Hopefully all of y'all know that our distance here is going to be 5, right? Got it? Okay, now the next one says find the length of each side, then calculate the perimeter. So what does the word perimeter mean? Distance around an object. Okay, this is important that you know this. Perimeter is the distance around an object, okay? Very, very important that we know that because we can't really solve this if we don't know that. Okay, so now, remember, we're going to use, now we can, we're going to find all three sides. So we're going to look at AC first because it's right here. right? So we can count it. 1, 2, 3, 4, 5, 6. So AC is equal to 6. Got that? Then we're going to look at AB right here. So we're going to look for the length of AB. And how are we going to do that? We're going to count our rise. Whoops. Let's see if I can do that again. 1, 2, 3, 4, 5. So we're going to do 5 squared. And we're going to do our run right here, right? See that? 1, 2, 3, 4. So 5 squared plus 4 squared, and we're going to take the square root of that. Don't forget to take the square root. So that's going to be 25 plus 16. So pretty sure that's going to be 41. Square root of 41 is equal to AB. And if we were trying to find the perimeter, we need to change that to an actual number. So that's going to be approximately 6.4. We're going to round it to 1 decimal, okay? Now let's find our third side. We're going to do this one in green. So that's BC, right? See BC right there? So BC is going to be equal to, again, we're going to look at our rise and our run, okay? So 1, 2, 3, 4, 5, and 1, 2, okay? So maybe I should have put those other ones over here. This was 5, right? And that was 4, okay? So 5 and 2, those are the numbers we're going to square and then add together and take the square root of, right? So we're going to do 5 squared plus 2 squared. So that's going to be 25 plus 4. So that's going to be the square root of 29. And that's approximately 5.39. Okay, now what are we going to do with all three of these sides? Because we want the perimeter. We have to do AC plus AB plus what? Plus RBC, right? So we're just plugging numbers, yes? So I'm going to put my 5.939 right there. Then I'm going to go back and do my AB, which was 6.4. And then we're going to go back and do our AC, which we counted, which was 6. So now we're just adding those three numbers together. And when we add those three numbers together, we get 17.79. That's the perimeter. Okay? Now we do. Now notice again with this we do. There's two of the sides we can count, right? 1, 2 here, so that one's 2. 1, 2, 3, 4. This one's 4. Now, do you notice that the rise and run of the other two sides is the same? I do. Okay? So this is 3 tall and 1 wide, right? 3 tall, 1 wide. This one's 3 tall, 1 wide. So, whoops, 1, 3 here. So those should be the same length, right? So we're going to add our 4 and our 2. Now we're going to find the other side, right? So we're going to do the square root of 3 squared plus 1 squared. It's going to be 9 plus 1. That's the square root of 10. Go ahead and find that in your calculator. The square root of 10 is 3.16. So don't we have 2 of those? So we're going to add 3.16 plus the 3.16, and that should give us a grand total for our perimeter. Perimeter is equal to 12.32, sorry. 12.32 is our answer, okay? All right, find the length of each side, then calculate the perimeter. Now notice, again, looks to me like this is a rectangle, okay? So we're going to go ahead and, so we're going to look at, let's just look at AB first. AB right here, A to B. So this is 1 up, 3 over, 1 up, 3 over. So when we're looking for AB, the length of AB, we're going to do the square root of 1 squared plus 3 squared. We just did this one, y'all. So that's the square root of 10. Well, now, let's check CD as well. It's 1 up and 3 over as well, isn't it? 1 up and 3 over. So that means that's AB and what? AB is equal to CD, isn't it? Okay. So the square root of 10 is 3.16. I think we just did this one a minute ago. So that's 3.16. Okay, so we got 3.16 plus 3.16. Now we're going to find the other two sides. And again, we're going to count. We're going to go down here and over. Okay, so 1, 2, 3, 4, 5, 6, and 1, 2. So let's count over here, make sure it's the same. 1, 2, 3, 4, 5, 6. and 1, 2, again, 1, 2. See it? Okay, so that, what does that mean? So for AD and BC, AD is equal to BC. How do we know that? Because they're the same numbers, right? So we're going to take square root of 6 squared plus 2 squared. So that's going to be 36 plus 4, which is 40, square root of 40. And again, we're going to round this because we're trying to find the perimeter, right? So we got to round these to make sure that we have the right numbers. So the square root of 40 is 6.32. So that means we're going to add the 6.32 here. And remember, you could just multiply these by 2. So when we add all 4 of those together, we get 18.98 as our perimeter.